Derivatives with exponentials, chain rule, Leibniz notation. So, here we have a function, and within this function we have a letter to the power of x. And when you derive said function, you get ln of that number multiplied by a number to the power of x. So, I'll show an example just after this, but here's just a basic chain rule equation. I'm not going to do the big ones, the longer versions today. I'm just going to do when you have x within u and u within y. So you have a function within a function, as shown, and this is what the derivative looks like. So, let's just get to an example. So, this won't be the chain rule. I'll just show you, show you what I mean when you're deriving a number to the power of x. So let's say 7 to the power of x. The derivative just like in this rule before, we write natural logarithm, that number, multiplied by that number to the power of x. I will do a video on the proof and how this happens, but for now, you just need to know basically this stays the same. You bring it down and you multiply it by a natural logarithm of the number. I hope you can understand that by visually seeing it. The 7 to the power of x stays the same, but you multiply that by ln of the 7. Okay, now we will do a chain rule example. So, y, we'll use the 7 again, and we'll make it to the power of x to the power of 4, take 7. So, you have a function, x to the power of 4 minus 7 within another function, and that would be 7 to the power of the unknown. So, we'll label u as x to the power of 4, take 7, and then we'll label y 7 to the power of u. So we have a function u within the function y. So dy over dx equals dy over du multiplied by du over dx, which says the derivative of y with respect to x equals the derivative of u with the derivative of y with respect to u multiplied by the derivative of u with respect to x. So find the derivative of u with respect to x, and we find the derivative of y with respect to the u. Okay, so u being x to the power of 4 take 7, the derivative of u would be just 4x3. The derivative, if y is 7 to the power of u, the derivative of that, you treat the u just like we did with the x before. So you'd make it ln 7 multiplied by 7 to the power of u. Just like before. Because in this one we did it with respect to x, so x was the variable. Here we're doing it with respect to u, so u would be the variable. So fill this in. dy over du ln 7 multiplied by 7 to the power of u multiplied again by derivative of u multiplied by derivative of u with respect to x, which is 4x to the power 3. So if we were subbing u again, let's say we have ln 7 multiplied by 4x to the power of 3 multiplied by 7. We'll sub in u. U is x to the power of 4 minus 7. And that is the first derivative of this up here. Another example. These will progressively get harder. Y equals sine 4x. Just adding a trigonometric function to it. So u will make 4x because that's the innermost function, and we'll make y sine of u. So we have a function within a function. Okay, so to derive this, we need to find the derivative of y with respect to u and multiply that by the derivative of u with respect to x. Derivative of 4 to the power of x, just like how we did the 7 to the power of x and the 7 to the power of the u, you just ln 4 and multiply that by 4x. So you just leave it the same basically and then multiply by ln of the number, which in this case is 4. And the derivative of y with respect to u, derivative of sine is cosine u. Fill this in. Derivative of y with respect to u, cosine u, multiply that by derivative of u with respect to x, ln 4 multiplied by 4 to the power of x. So we can, rearranging it won't really make it look much neater, so we'll just leave it the way it is and fill in the u. Cosine 4x to the power of x, because that's what u is, ln 4 to the power of x. Now we'll do one more example. Let's say y equals 10 e to the power of x plus 5 to the power of x. So we have our function within our function of 10. U will make e to the power of x plus 5x to the power of x, and we'll make y equal to 10 of u. So we have a function u within the function y. So we need the chain rule. Derivative of y with respect to u multiplied by the derivative of u with respect to x. The derivative of u with respect to x, u being x to the power of 5, u being e to the power of x plus 5 to the power of x. First, on this side of the plus sign is e to the power of x, so the derivative of that is just e to the power of x. I have videos on e to the power of x and derivatives if you want to watch them, but I'm not going to really explain it here. That's just what it is. The derivative of e to the power of x is e to the power of x. The derivative of 5 to the power of x is ln 5, I'm not going to fit this in, multiplied by 5 to the power of x. I'll have to rewrite that down here. But derivative of y with respect to u, derivative of tan sec squared. So if we rewrite this out, derivative of y with respect to u, sec squared u, multiplied by the derivative of u with respect to x, e to the power of x plus ln 5 multiplied by 5x. This pen's running out. This one's no better, but if we fill in the u and make it look a little neater, we have sec squared, u is e to the power of x plus 5 to the power of x, multiply that by e to the power of x plus 5x ln 5. And that is the first derivative of this function up here. Thanks for watching. Hope this helped.